Okay, so back to Lowell's map. Remember, the field trip target is down between these two sections, 35 and 34 and 35. So Lowell, in his survey notes, tells you how he started at the south end of section, at the very south edge of the map, and he walked northward along to define the section line between sections 34 and 35. Okay, so projecting the area of that section line onto a modern air photo, you can see our field trip, that there's a launch up and upper left, and we paddled upstream, and we went a little bit beyond, farther upstream to look at some red cedar. And then we went back to the area of the section line, and poor navigation failed to find it. In laser topography, it looks like this. And if you can superimpose the air photo on the laser topography and get a sense of the marsh with its, oh, and let's see, do I have good there. Okay, so you notice there are some spruce out. We talked about that already. There's spruce out in the marsh. One of them has been cored, and in 1992, and it had something like 137 rings or more. And so spruce were the natural restoration here had gotten to the point that spruce were able to get a hold on the bank, but no red cedar. Okay, so first we're going to go to this Halloween skull and crossbones up there to visit two of the three trees that have final rings from 1699, and therefore record death either during the dormant season between 1699 and 1700. And then we'll go down to the likely area of the bearing trees. And the David Yamaguchi sampled at the sites shown in red. Okay, so here's one of those sampled trees. It's a particularly good one because there's a bank exposure that allows you to see a buried forest floor and to see mud above that buried forest floor that contains in growth position the below ground stems and attached leaf bases of Triglocan marinima, a salt marsh plant that would be that red cedar would not like to live next to. And you can see the condition of the red cedar is pretty typical. The center is long gone, and it's sort of just a shell there. And this is one that did give a last ring date of 1699. The earliest ring in the sample was from the time of Columbus, but there are probably earlier rings that are interior that are not preserved. Here's another one of this one's up against an upland, and this picture from I think 96, and I've labeled at the bottom a little dashed line that the high water gets up to the area of the dashed line. David Yamaguchi's sample from this one has lots of rings going back. He's got 232 rings in this tree back to what? So that's 1440 something or other, and that's the position on the tree where he got his sample. And then in the 90s, I made connecting cuts down all the way into bark-bearing roots to ask the trees when they died, because David had dated the rings in the trunk only. And after the Japanese researchers told us about January 1700, we went back to trees that David had sampled. And you can see in the 2016 picture that high tide has flooded part of the hole that I dug to get down to the bark-bearing roots. And that's one of the bark-bearing roots from that tree. The bark has been removed by chainsaw rattling it off, but you can see how smooth and well preserved the exterior is. Okay, so John Lowell and our hunt for bearing trees. So Lowell starts, remember Lowell's walking this section line, and I've taken a piece of his map, added color to the marsh. And at the very south edge of that strip map is where he starts walking. And he's got a compass direction that says what his magnetic declination is, because he knows that his compass is pointing one way and true north is another, and he's got to run true north. So, and he's using a unit called chains, an old unit that's equivalent to about 20 meters. So at 36 chains, he says in his notes, leave timber and enter marshland. And then at just shy of 40 meters, he hits a slough that's pretty wide. And then after he does some stuff, we'll see in the next slide, he says, now I leave the bottomland and enter green timber. So he's going to tell us about using cedar as bearing trees at the slough. But it's interesting that he then says green timber, as if he's been dealing with something other than green timber out in the marsh. And then he continues all the way up to the section corner at 80 chains. So he's responsible for putting a monument at the halfway along this line from 0 chains to 80 chains. And that falls, as you can see, the 40 chains falls in the slough. So his notes are written at the bottom, but I've transcribed them easier to read up at the top. And he tells you, and then I've put little labels that are keyed to this cartoon index map. So you can read that and parse his notes. Okay, so the little red box is going to be where he's going to put his witness post. That's going to be a substitute for a post that he would have put at 40 meters, but 40 meters is out in the slough. And then he's obligated for one of these quarter section marks, he's obligated to have 2 witness trees if they're available. And so he tells us that he used cedars. And he's way out in the marsh, you know. So it's pretty clear he's using the kind of cedar that we saw in that oblique air photo of the Bone River, that sticking out in the marsh, dead. And then his saying that he enters green timber is reinforcement of that. So, and this is probably the earliest specific recording of this kind of earthquake evidence in Washington, in anywhere Cascadia, written record. All right, so a surveyor more competent than I am went out there in January 2004 and found the GLOBTs, the General Land Office bearing trees, right? And finds the 30-inch one that the surveyor describes as a root collar. You can understand that the way that the red cedar are so hollow. And then he finds another one, the 36, and they're in the same directions pretty much that Lowell gives you. And then he's giving you the distances to those in feet rather than in chains. But he's confident that he's nailed it. And he does say that he couldn't find anything that had been written on the tree, because they were supposed to put marks on the tree, but it's easy to imagine that falling off. And then he says he replaced the witness post. Jackson, I don't know. If I'd had these notes with us, we would have known to go looking for a 3 1/4-inch aluminum cap on a 5/8 rebar. And then he creates new reference points. 2 different spruce, and then he finds yet another reference point, another spruce, with grown over notches from an axe, probably, right? And he says traces of blue paint. So it should be possible to to really nail down what Lowell saw in 1855. But I failed. Okay, so in the bigger picture, we've been looking just at the very right-hand part of this timeline. With a preceding earthquake back around the year, maybe around the year 1100, and some lowering of the landscape, and there's a bit of a pattern in the sequence of tidal wetlands that got dropped down in Southwest Washington, where some were very widely forested. 1700 is such the case. Another one around the year 400 is that way. And others were very sparsely wooded, as if not very much time or rebuilding or ecological restoration had taken place before the next earthquake reset the successional clock. And so that becomes, in this way, the restoration ecology of tidal wetlands informs estimates of the time that elapses between successive earthquakes, and because the more time that elapses, the lower the hazard. This also affects estimates of hazard and also the regularity. You can see that this this repetition here is far from regular, and so that also plays into estimates of how of what your chances are of getting another one of these earthquakes in the next umpty years. So I guess for the last slide here, for the if one looks ahead with the information that's currently available, there's confidence that the fault rupture be offshore. There's quite a bit of discussion as to whether our part of the subduction zone dependably produces earthquakes of magnitude 9, or sometimes produces earthquakes smaller than that. There are also open questions as to whether during the lifetime of the red cedar we've been looking at, there was a rupture of the subduction thrust offshore northern Washington, but not offshore southern Washington. That's an example of that. But with the history in the previous slide going back 3,500 years, you have something like a 1 in 10 chance of 50 years for an average. And as for tsunamis, for the Wahkiakum part of the MRC, there's the well-known example of a piece of Columbia River basalt splashing into the Columbia in 1964 or 65 and making a tsunami that took a life on Puget Island. So there are ways that earthquakes shaking can set off inland waves as well as the big coastal ones. And a long-term effect, you think of, there was a sea level report the National Research Council did some years ago. Some of you've probably seen, and with projections for sea level rise on our coast. And the authors made a point of saying, you get another one of these big subduction zone earthquakes with a meter and a half of lowering of land, and you accomplish in an instant what we're projecting will take the rest of the 21st century to accomplish. So anyways, let's leave it at that. Thank you very much for your attention.
Hey there, Brian. Thank you so much for presenting on that. It was super interesting, and I got some chats that we're all asking about getting access to your presentation. So that is now uploaded on the website for anyone who wants to look at that more. And I see we have a Key has raised their hand. So if anybody else has any questions, you can just follow.
Oh, good.
Key, what you got?
I just really wanted to say hi to Dr. Atwater. And Dr. Atwater came and helped me do two site visits down on the Nowacum, and with the biggest group he's ever had out there, 47th and 48th graders. And we lost a few kids, but we were able to get them out. And then the next day, well, and Jim Rose was helping me, and so I had the construction class make walking planks. And when Dr. Atwater first got there, I said, I want to try our walking planks so we don't lose our kids in the mud up to their waist. And he says, oh, I don't think so, Key. I don't think that's a good idea. So anyway, we lost a few kids. We were able to get them all out. We didn't lose any shoes. And then a couple days later, Dr. Atwater had met with Scott McDougall, and I asked how my second site visit went. And I didn't get any kids dirty, and we didn't have to dig any kids out. And Dr. Atwater said that maybe he should listen next time. So those planks are there for everybody to use so they don't sink up. They're hidden up in the woods there, and it makes for great viewing of the tsunami layers there. And also the trip up to the Ghost Forest is absolutely amazing. So I just really wanted to say hi to Dr. Atwater.
Well, thank you, Keith. Thank you for the lesson on keeping kids clean. There's a part of me that felt that the experience of getting mired in the mud is educational. So, but
and I would agree. But the bus superintendent wanted to kill me, and I don't think he would ever let me take them out again if I didn't change things up, because I had the bus dirty from top to bottom, and it was a very good thing that Goose Point Oyster was there to wash off some of the mud, but the bus was a disaster. So anyway.
Yeah, but you know, your point, Key, that was wonderful what you did there to arrange for that trip, and this speaks to and maybe you want to do you want to just say something about the program, the umbrella under which that it wasn't quite from that directly from that program, but which had occurred. What was that program called? Teachers on the Leading Edge or something like that. Or maybe it was a successor program. But anyways, National Science Foundation supported training workshops for what? There could be as many as 36 participants in the workshops, and they went for 4 days or 5 days, and the most recent series of them would serve about half of the participants would be K through 12 teachers, and another would be quarter would be park interpreters. And then there were people in the community who were particularly active in earthquake and tsunami preparedness. But that's the kind of program that just needs, it seems like that kind of thing just needs to be institutionalized. And you know, whether Sea Grant could help make that happen, I'm not sure. Jackson, you're surely aware of that history there. It'd be nice to revive that kind of thing so that whether they get the bus dirty or not, these kids have a firsthand acquaintance. They're not being told in a textbook or in a PowerPoint slide about earthquakes. They've actually seen, in tsunamis, they've seen the evidence for themselves, the fact on the ground.
Can you wait?
That program originally I went to, it was the CTEP program.
Yes.
And I'm drawing a total blank of what CTEP meant, but it was earthquake, tsunami education, earthquake education program.
No.
And what we had done, it was a program at the South Bend schools, and it was through their honors or their leadership class that we were teaching about preparedness and whatnot. And I had the kids do the whole preparedness fair. They came up with the skits, they came up with the posters, they came up with the vendors, and as part of their preparedness trip and plan, we took them down to the Niawacum, and it was one of those things that the kids will remember for the rest of their lives. And it was really amazing that they got to have Dr. Atwater there. I think the 7th graders got to have that experience with him, and it was really awesome. And of course, the kids that got muddy complained, and the kids that didn't get muddy,
not all of them.
Not all of them, that's true. But the kids that didn't get muddy, they complained that they didn't get muddy, and you can't win. But it was a really great trip for the kids, and it just led them into more preparedness. And anyway,
yeah.
So
No, but hats off to you. You did a lot of this, I think, in a voluntary basis, and you made it happen. So thank you for that.
Yeah, let's move on to one more question now. Brian has a question. So let's do that, but let's keep this moving. We'll save questions for the end too, because I think there's more people out there that will want to do queries. So Brian?
Hey, Brian, thanks. Great presentation. Really enjoyed that. I can't figure out how to raise my hand, so it's this way.
It's good.
Anyway, I'm just gonna say, number one, we have quite a bit of acres up in Willapa Bay on the peninsula. You might have already been out there, but it's just huge. I guess tidal marsh area that's full of those stumps you're talking about, of all different sizes. And then some of them a little on the north and sort of extend out where they've been eroded away by the bay activity, and most of them are up in the field. So it plays hell when you hit one with an ATV, I'll tell you that, because it pretty much stops them dead in their tracks. Those things are solid. It's amazing they're that old. But I was going to ask you, what are your thoughts on, is there any reason to believe that if we have another subduction that it's going to be any worse than the last one?
I don't know. If you think you're thinking in terms of the physical part of it, not in terms of its consequences, right? Because there's hazard, and then people speak of a broader concept of risk, where risk is you take hazard and multiply it by consequences. So the consequences of the next one will likely be greater just in terms of the human exposure, which isn't to say that there weren't people in harm's way in 1700. But you're asking whether the next subduction earthquake has a good chance of being larger than the one in 1700. Is that the idea? And the tsunami consequently larger?
Correct.
Is that the question?
Yeah, that's the question. Yeah. And I'll just throw in there that why I'm asking is because I know, I live on the peninsula, North Beach Peninsula, sometimes incorrectly referred to as the Long Beach Peninsula, but we have seen over the past 30 years this nonstop filling of wetlands, houses built in swamps that we all, folks have been around a while, thought there's no way you could build a home there. And now we've got houses just inundating, encroaching closer and further into wetlands. And, I know those are going to be, I'm pretty sure they're going to be heavily impacted during a tsunami. Some of us were, I think, wise enough to get on top of a ridge, hump of sand. So really what I'm asking is my house still going to be here if that happens?
Yeah, so that the state geology agency working with the what's it called, the it's in the state military department, the emergency management division of the state military department. They've produced tsunami inundation maps and tsunami evacuation maps, and they're in the process of completing their second generation of inundation and evacuation maps. And the second generation paints a picture that's not as rosy as the first generation.
Wow.
And that's because of the assumption that they've made. They've decided that to err on the side of caution, they would choose a tsunami source that's pretty unlikely. That probably something like this has happened in the past, but most of the earthquakes don't achieve that don't cross that bar. But they've set a very high bar, very high standard for their next set of maps, their current set of maps that make things look really tough at ocean shores and Westport and so on, and probably also for the Long Beach Peninsula. So you could see what those maps look like and compare them with the set with the maps that were put out, I think, in the year 2000. And there will be a big difference, and it's rooted in the assumption. It's not like the understanding of the hazard has changed in some fundamental way. It's more nearly a judgment call as to what I don't know what level of hazard you want to present to people. And I think it was driven in part by the 2004 Indian Ocean and 2011 Tohoku disasters, that those were unexpectedly large events, right? And so to prepare Washington Coast for unexpectedly large events, they've gone to a fairly extreme scenario. And the only downside to it is that it makes the damn things look unsurvivable. And if you think that that's likely, if you were to make a map that shows the probable tsunami as opposed to something that's closer to a worst case, you get a very different look. So these are really difficult issues for people.
Thanks a lot. Great explanation. I was going to say too, if you ever get out this way and you want to look at some of that, feel free to get a hold of me. I'm in the book, and or most of these people know how to get a hold of me.
Thank you.
Take you out there and show you what we've got down here.
Thank you very much.
This was a